In this video, we're going to talk about how we measure hearing in terms of both pitch and volume. So the ideal range of human hearing is from 20 hertz to 20,000 hertz, or 20 hertz to 20 kilohertz. And I say this is ideal because many of us don't actually hear that. I'm sure that my high range hearing is less than 20 kilohertz now. As you get older, you lose that high end. Some of you may have hearing up to 18 or 19, and we're going to actually, in class, do a little test to see who can hear what. But hearing, the way we measure hearing is logarithmic, meaning that the change in pitch is not steady. So from 20 hertz to 40 hertz is an octave, right? Every time you double the frequency, you get an octave. So 20 hertz to 40 hertz is an octave, then 40 hertz to 80 hertz, etc. So at 1,000 hertz, it's 1,000 hertz till you get to an octave higher, where it was only 20 hertz down at the bottom. That's what I mean by logarithmic. And our volume perception is similar. And we'll get to that in a second. So this is called the Fletcher-Munson curve. And there's actually a newer version of it, but even the newer versions, they still call the Fletcher-Munson curve because this was sort of the original idea. And what this does is it shows how our hearing tends to change at in relationship to both pitch and volume. So a phone, 10 phones is the volume of 1,000 hertz at 10 decibels, right? So this is sound pressure level, which we measure in decibels. That's another, sound pressure level is another word for volume. And then this is frequency coming this way. So you'll see at this very soft end, at 1,000 hertz, as things get lower, the sound has to be louder for us to perceive it at the same volume. So at 20 hertz, the sound has to be 75 decibels for us to perceive the same volume as 10 decibels at 1,000 hertz, right? And at 4 kilohertz or 4,000 hertz, it only has to be, it's down to next to almost nothing. That's like 2 or 3 decibels to perceive the same as 10 decibels here. So you see there's a bump and another level of sensitivity here. So this sensitive spot here in the, 3 to 4 kilohertz range, actually represents, that's why human speech works the way it does. All of this is the phonemes in our speech, right? So there's a fundamental pitch that you hear from my voice, but all of the upper frequencies of how I form vowels and other sounds happens up in this range, which is why it can be difficult to understand people speaking, say, like in a loud club, if there's music happening, because this stuff gets washed out by other sounds. So decibels, we talked about that. It's a measurement of sound intensity. The sound pressure level is measured in decibels relative to human hearing. So 0 decibels is the softest anything can be. And so every time you double the sound pressure level, you get about a 6 decibel increase. That's double the sound pressure level. It's not actually, like, it doesn't feel twice as loud to us. Let me get my little handy dB meter here so you can see this. If I don't make any noise, it gets down into the 40s. As you can see, as I talk, it gets louder. And if I talk even louder, it goes up. So like this close to me gets to close to 80 dB. Distance matters greatly as we measure those things. And our in-class exercise time, we will play with some of that as well. So pitch is also perceived logarithmically. We talked about that. An increase of pitch is 1 octave doubles the frequency. So A can be 55 hertz, 110 hertz, 220 hertz, etc. So we measure loudness in decibels. That's a measure of sound pressure level. We measure pitch or frequency in hertz. And the next video, I'm going to show you the app that sort of ties a bunch of these things together that I'll give you to download and play with.